X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Hi, algebra students, Mr. Lawrence here, and we're talking about the quadratic formula. Actually, I'm singing about it. Why don't you sing along? Follow the bouncing. Oh, let's do a bouncing smiley face. Where are my smiling faces? Smiley face, where are you? Creative pen, is it in there? Oh, there it is. There's a smiley face. All right, back in the old days, they used to say follow the bouncing ball. Let's follow the bouncing smiling face. Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Yes, that is the quadratic formula, and it's very useful. You see, we're going to be graphing really soon with quadratics, and we can do some really cool problems with them. But the quadratics, they are going to look like a parabola. Remember that U shape, and the parabola might open upward or downward. The quadratic formula is very useful. You might notice that part of the equation I have, or the formula I have written in red, and we'll talk about that in the next video, but part of it I have in green. The green part is what we're going to talk about today. The green part is called the discriminant. And you'll want to get this down. It tells us how many x-intercepts there are. Okay, so in other words, these parabolas that I drew up here, there's going to be an x-axis, right? And then, of course, a y-axis. Okay, the discriminant will tell us how many times the parabolas will cross the x-axis. They might cross twice. They might cross, the one on the left is crossing once here. The one on the right is still crossing twice. Or they might not cross at all. Look, the one on the left isn't going to cross the x-axis. See it there? Okay, the discriminant will tell us this. All right, now by the way, these x-intercepts, you're going to hear me call them things like zeros, roots, or maybe even solutions. Very, very important to know that. Very important to know that. So let's see, I think I can get rid of my shade here. I'm going to use this discriminant, the green part of the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I'm going to use the green part of the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I'm going to use the discriminant, which is the green part of the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant, and that's going to tell me how many zeros there are. Now, I'm not going to tell you how I know yet. I'm going to go ahead and do a problem. So, first thing I need to do, if I want to do b squared minus 4ac, I have to identify ABC. So, time to switch songs. ABC, easy as 1, 2, negative 8. And now I will use b squared, b is 2, notice I put it in parentheses, minus 4, a is 1, it's in parentheses, and c is negative 8. Now a lot of you have problems with the order of operations, and you're going to get this part wrong because you're not going to do the order of operations correctly. If you listen, if you pay attention, you'll see how to do it. I'm going to do my exponent first, I'm going to get 4. Now I'm going to do negative 4 times 1 times negative 8. Well, that's going to be positive 32. Yeah, it's not a negative. It's negative 4 times 1, which is negative 4. Negative 4 times negative 8 is positive 32. The two negatives are going to cancel out because it's all multiplication. All right, so then I add those together and I get 36. And I know there are going to be two solutions. And again, I haven't told you how I know that yet, but let's go ahead and jump to that. Let's see here. It says here that if the discriminant, the b squared minus 4ac part, is greater than 0, there will be two x-intercepts every single time. If you do your discriminant correctly and you get 100, there's going to be two x-intercepts. If you do your discriminant correctly and you get 1/2, a positive number greater than 0, you will get two x-intercepts. Again, they could be called zeros, they could be called roots, they could be called solutions depending on the context. Now, if I know there's two solutions, two roots, I'm going to go find them. How am I going to find them? I'm going to use the quadratic formula. What's the quadratic formula? I am so glad you asked. X equals negative of b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative of b plus or minus the square root of b squared minus 4ac all over 2a. Now you notice I didn't fill in this part. You know why? Because I already did the work up here. This is the discriminant. I'm just going to put 36 in there. Yeah, I'm going to do x equals negative b plus or minus the square root of the discriminant all over 2a. I already did the work for the discriminant. Why would I go and recalculate it? I already know it's 36. Now, I'm going to follow the order of operations. I'm going to simplify this as best I can. So I'm going to get x equals negative 2 plus or minus, what's the square root of 36? Well, it's 6. And that'll be over 2. There's two answers here. There's the answer to the problem, negative 2 plus 6 over 2. And there's x equals negative 2 minus 6 over 2. And so I'm going to get x equal to negative 2 plus 6 is 4. 4 divided by 2 is 2. One of the x-intercepts occurs at 2, 0. I guarantee it. All right. The other one is going to be x equals negative 8 divided by 2, which is negative 4. The other one occurs at negative 4, 0. Now, we're not actually graphing yet, but just to show you I know what I'm talking about, I am going to bring up Desmos and type in the original equation. Let me see, what was it again? It was x squared plus 2x minus 8, x squared plus 2x minus 8. All right, let me get in right mode here. Let's see, let's get rid of this one. I think it was plus 2x. And was it minus 8? I think it was. Oops. X minus, and then 8. And look at this. I think I can zoom in a little bit. Look where this thing is crossing the x-axis at positive 2, 0 and at negative 4, 0. Did you see that? There's my parabola shape. Okay, down here is a vertex. We'll learn about finding the vertex tomorrow. And sure enough, I'm crossing at 2, 0 and at negative 4, 0. All right, now we're not going to check that on every single one, but I just wanted to show you I know what I'm talking about. All right, let's go ahead and calculate the discriminant for this one, for problem number 2. Well, first we got to go A, B, C. Easy as 1, 5, negative 2. All right, so I've got 1, 5, and negative 2. And then we're going to do the b squared minus 4ac part, the discriminant. So we're going to do 5 in the parentheses, always in the parentheses, minus 4. Why isn't the negative 4 in parentheses? Because it's part of the formula. But anything I substitute in, I'm putting in parentheses. So negative 2. So this will be 25. And look, I've got two negatives being multiplied. I'm going to get a positive, and I'm going to get 8. 4 times 1 times 2 is 8. And so this is going to equal 33. Okay? So again, my discriminant was greater than 0. I'm going to have two solutions. Let's go find them. We'll have to use decimal approximations for this. So let's go. X equals the negative of b plus or minus the square root of the discriminant. I already did the b squared minus 4ac part. I don't want to do it again. All over 2a. And so what we have here is we have negative 5 plus the square root of 33 divided by 2. And we have x equals negative 5 minus the square root of 33 all over 2. All right, so now I'm going to go to a graphing calculator because the square root of 33 is an irrational number. So I'm going to get a decimal approximation, but it's not going to be the right answer. It's just going to be close to the right answer. So my calculator's coming up here. All right, let me get out of this graph mode. And let me see, what did I have there again? Hold on a second. Negative 5 plus rad 33 over 2. So I'm going to go parenthesis. I'm going to put my numerator in parentheses. Negative 5 plus the square root of 33. Oops, I don't want to close that parenthesis. I'm on a newer model calculator. Sorry. Ones in my classroom, you'll probably have to close that parenthesis. All right, and then I'm going to divide it by 2. Right? And so the first root, or first solution, is going to be about 0 and 37 hundredths. Yeah, 4/10 maybe. And then to do the second one, I'm going to use my second enter function. I love these calculators for that reason. I don't have to retype everything. And I know it's -5 minus the square root of 33, so I'll just edit that and hit enter. And there is my second root or solution or x-intercept. So this one will cross the x-axis at 0.370, and the other x-intercept will be -5.370 for the y-coordinate because they're on the x-axis. Okay, now we're not always going to get 2 solutions. The parabolas don't always have to cross the x-axis twice. You may know that from paying attention. Let's see what happens with this green one. Let's see. Oops, my airliner is not on. Turn on airliner. Oh, we're connected. That's a good sign. Sign, everywhere, sign. All right, first of all, I need to identify A, B, C. And that's easy. That's 4, -12, 9. All right, and so B squared is -12 minus 4AC. Well, 12 squared, -12 squared is 144. Ooh, that's gross. All right, and then I'm going to subtract, let me see, 16 times 9, I think that's 144. Yeah, 4 times 4 is 16, times 9, sure enough, 144. In this problem, my discriminant is 0. It's not greater than 0. Geez, I wonder what's going to happen. Well, let's see here. When b squared minus 4ac equals 0, then we get 1 x-intercept. This parabola will be sitting on the x-axis. Yeah, there's 1 x-intercept. That's right. All right, let's go find it. Let's go find it. And this is actually the long way to find it. Later on, when you get good at these, I'll show you a shorter way to find the x-intercept. So to find the intercept, I'm going to have to use the quadratic formula. What's the quadratic formula say? Sing along with me, Rocky. X equals negative of b. Notice b was -12, and now it's +12. Plus or minus the square root of the discriminant. This will be a real easy part. All over 2a. Well, x equals 12. The square root of 0 is 0. Plus or minus 0. That's kind of a waste of time. I'll write it down. But when I add 12 plus 0, I get the same thing as if I do 12 minus 0. That's why there's only one answer. That'll be over 8. So my one solution is going to be at 12/8. If I simplify that, I get 4/3. And since we're talking about an x-intercept, I'm going to use a mixed number. I'm going to go 1 and 1/3, and then 0. There's my x-intercept. Piece of cake. This stuff is too easy. Got to pay attention to the details. All right, let's try number 4. We got to identify A, B, C. Easy as 5, 3, 1. All right, now we'll use the discriminant. B squared minus 4AC, which is 9 minus 20, which is -11. Well, the discriminant's less than 0. The first case was greater than 0, first 2 cases. We had 2 solutions. When it was equal to 0, we had 1 solution, 1 root, 1 x-intercept. When it's less than 0, there's going to be no x-intercepts. That doesn't mean we can't graph the parabola. It just means there are going to be, I should change that to 0 x-intercepts. Yeah, I'm going to change that to 0 x-intercepts. There you go. So, b squared minus 4ac greater than 0, we cross the x-axis twice. b squared minus 4ac equals 0, we cross the x-axis once. And b squared minus 4ac less than 0, we don't cross the x-axis at all. So in this problem, if we're not graphing, if we're just trying to find the roots or solutions, well, there aren't any roots or solutions because the discriminant is negative. See, we can't take the square root of -11. So if we filled it out, it would look like this. But this part right here is an imaginary number. You can't take the square root of -11. So we don't have any more work to do. We're done for just this part of the problem. Now later on when we're graphing, we'll have more work to do. But for just finding the roots, this one doesn't have any. It does not cross the x-axis. All right, let's see here. Do I have anything else? I think that's it for the video. Let me just double check. Oh no, here's 2 you try problems. I want you to try them. Go ahead and pause the video and you try them. I want you to find out how many solutions there are and find them if there are any. Okay, here come my solutions. Hopefully you've already tried. A, B, C. Easy as 1, 1, 4. All right, so I'm going to do b squared minus 4ac. Okay, and that'll be 1. It'll be minus 16. That'll be negative 15. I got a discriminant of negative 16. There are no x-intercepts. The parabola will be able to be graphed once we know how, but it won't cross the x-axis. All right, let's try number 6. We've got A, B, C. If you haven't tried, pause the video and try it. 16, negative 40, 25. All right, so I've got b squared minus 4ac. And when I do that, I get 16 with a pair of zeros, so 1,600. Now, work smart, not harder. Don't do 4 times 16 times 25. Do 4 times 25 is 100, times 16 is 1,600, and it'll be negative because there's only one negative. So look at that. My discriminant is going to be 0. So there's only one solution, one x-intercept. So I'm going to go find it. And so to find it, I'll use the quadratic formula. What's the quadratic formula, you say? X equals negative of b plus or minus the square root b squared minus 4ac, otherwise known as discriminant, all over 2a. Oops, I left a b in there. I didn't mean to put a b in there. I'm so sorry. I hope you didn't get stung. Ha! All right, let's put a positive 40 there because we want the negative of b. So x is going to equal 40 over 32. If I divide by 8, I'm going to get 5/4. And so the x-intercept will be 1 1/4, 0. That's the only place it'll touch the x-axis. All right, that's your video for today. Mr. Laurence signing off.